Okay, today's video is about well water and using a well water pump to bring up well water to use on your sprinkler system. I'm going to show you my system. I keep it covered with a standard rain cover for a window to keep the rain off the pump. It's an outdoor pump. It's meant for being used outdoors, but you're better off keeping it covered because rain destroys everything. It's a Goulds pump, a GT15 pump. I'll show you the specs on it if you can read it. It's 1.5 horsepower. It's either, this pump could be wired for either 115 or 230 volts, which is really like 120 or 240. It rotates 3,450 times per minute. It's a pretty powerful pump. It uses either 16.8 amps / 8.4 amps, which means that on 120 volts, if it's wired to 120 volts, it'll use 16 amps. If it's wired to 240 volts, it'll use 8 amps. And basically, as you know, if you are setting this on 240 volts, you only need half the amps, half the current to run the pump. The maximum load of amps that this pump uses is 21.4 on that's on 120 volts, or 10 amps on 240 volts. It's 60 hertz, and that's basically the pump. I'll give you a good view of it. Now, what the pump does is this: it pulls in water from in the ground. When they install it, they dig a hole using air pressure down. He told me he started to hit water at 25 feet, and he dug down 35 feet to get a good water supply. The water gets pumped up here into the pump, and then gets pumped up out down into the sprinkler system with the valves. There are 4 zones here. So the 4 valves pump out the water, let the water go out to the different zones in the sprinkler system. Over here, the water comes up, as we said, and here's a check valve. There's a valve over here that basically, when the pump stops operating, the water is held up till here. So the water doesn't have to be pulled up 35 feet each time you turn on the pump. It saves a lot of energy. In the winter, you open this up, which breaks the vacuum, which lets the water fall down the 35 feet to the bottom so the pipes don't freeze. This side is after the check valve. It just gives you access to that. A thing to know is when you're priming the pump the first time, it's very difficult to get that to get the water up the first 35 feet. So what you do is, some people, there's an opening on top. In this case, it's for a garden hose. They pour water in here, and that helps prime the pump. But I found it's a lot better to, we've had more success adding water to this side of the check valve. So it feeds the pump when the water comes in, and it's able to create a vacuum to suck the water up to 35 feet up here. Now, there's 2 things you want to know. Is you want to, when you install this pump, you want to make sure that the guys who do it aren't lazy, that they're wiring this for 240 volts. Because they're lazy. Everyone today is lazy, and they want it to as least work as possible. So they'll just put in 120 volts, which is basically, it's 12-2 wire, which is 2 hots and a ground. Or basically 2 hots, a neutral, and a ground. You want them to use 12-3 wire, which isn't much more expensive for this 3 feet of space, and that allows you to bring 2 hot lines in. Hence, it'll give you the 240 volts. Now, the reason is everything runs better at 240 volts. All of your appliances, they use it in Europe, and your pumps use half the amps, and they also run cooler. Even so, this pump gets pretty hot. I would say this part of the pump hits over 100 degrees. That's how hot it gets. The other thing you want is you want them to give you a connection for a hose. I made them give this to me because, first of all, the water's free. You don't have to pay for water. I mean, water in this area is really quite expensive. I think without this system, using regular municipal water, my bill would be about $150 to $200 a month. With this system, my bill is about $25 to $30 a month because much of the water goes to watering the lawn. And basically, so getting back to the pump, this can save you a lot of money over time. So you want this sprinkler, this hose connection, so you can connect this to the hose, so you can water your garden if it's not already part of the sprinkler system. You could wash your car with it. You could hose down your driveway, which is great. I mean, you could use thousands and thousands of gallons to hose down your driveway, and it doesn't cost you a penny. I mean, well, not in water anyway. Electricity is another question. That does cost you money to run the pump. But basically, you can use thousands of gallons. It doesn't cost you anything, and that's really very helpful. So you want them to give you this, and when they connect this, you want this connected directly to the pump, the way it is here, because you don't want them to make this its own zone. Because if they make this electrically one zone, and you have it hooked up to a zone, to its own zone, then if someone ever turns it on to that zone, and the hose isn't open, then the pump's is going to be pumping water with nowhere to go, and that's going to burn out your pump, like in an hour. That'll destroy your pump. So what you want is, the only way I could turn this on is if I'm turning on one of the 4 sprinkler zones. So the water is always pumping to at least one of the zones if I'm using the hose. Now, yes, it might mean a little less pressure to the hose because it's also at any one time, running some of the sprinklers, but it does prevent the pump from burning itself out. Should you, if you would accidentally, if this were its own zone and you didn't have the hose running, then the water would have nowhere to go, and it would, as we said, it would get destroyed. It would burn out. Now, the other thing to note is it does use a fair amount of electricity. At 240 volts, this says it would use 10 amps, which is about 2,400 watts, which is a lot. I think it's a little more than a 1-ton AC unit. So if you're using this a couple of hours a day, it will cost you probably about 40 cents an hour is my guess, 40-50 cents an hour to run, but it's still a lot cheaper in terms of using water instead of using water. Okay, sorry for the background noise. I'm going to show you how the system works. This is a standard controller. It's made by Hunter. It's waterproof, so it's outside. And this controls the 4 zones that we have down there, the 4 sprinkler zones. And you can program it 7 days a week, different days of the week. It has, you can program the start times, the run time, how many days a week for it to run. You can, it's basically a small computer, and it really is great. It lets you program it multiple times a day. And what this is, this puts out, when it wants to turn on, it basically sends 24 volts to the switch, the electrical switch that turns on that zone, and then it sends 24 volts to this relay. Here is a relay box, and what this does is this sends 240 volts down to the pump. So it's a relay, and a relay is just, if you don't know, it's just a switch. Basically, so you could use a thin wire, a 24-volt wire, into this box, and then when you do that, it'll then send 240 volts into the pump, so you don't have to run the 240-volt wires back and forth. You can look up relays on the internet. So we'll give this a start, and we'll see how much electricity it's using. And hold on. Okay. Now I have my fluke multimeter here. I don't know if you can see it. This is cheaper. This is a Mastech current clamp. It measures the current running through the wires. I got it on eBay, So of course the instructions aren't that helpful. Okay, so what we're going to do is this basically converts amps to millivolts. It measures the amps on a wire, and the benefit is you don't have to run the wire through the multimeter to measure the current flowing through. You can just use this. It's basically a, I think it works the way a transformer works on the light pole. It's basically like a magnet, and as the electricity runs through this, it pulls off some of the electrons and it measures it. And it's able to measure the amps. And then it converts that into millivolts, which this multimeter can measure. So we're going to clamp it around. I just want to make sure you can see it. Here's the multimeter. Here's the clamp. Here's the relay box. And we're going to clamp this around one of the wires, the red wire that you see. You only want to clamp it around one wire. If you clamp it around more than one wire, it's just going to mess up the readings. You're not going to get a real reading. And we're going to set the multimeter to measure the minimum and maximum that's used. And we'll turn this thing on and we'll check it out. So the pump, you just hold this button and it'll turn it on. Hold on. Okay, it's going to start. Now the pump is starting. You heard the click. The relay box click sent the 240 volts to the pump. And now let's check it out. What the meter is saying is this pump, the maximum this pump used, which is on startup, is 23 megavolts, which is 23 amps. And you can hear the water being brought up by the pump. Now let's check out. The minimum was 0.4. That doesn't mean anything. And let's just see what it's using now. It's using, it says 8 millivolts, which is 8 amps. So it's using about 8 amps of power. At 240 volts, let's see, my math isn't that great, but it's about 2,000 watts. So this is using, and this is using 8.1 amps. This said that it generally uses, I don't know if you can read it, but it says on it that it uses 8.4 amps. So the pump is about correct. It's using 8.1 amps, which is a little less than the 8.4 amps it says it'll use. But it's basically using about 2,000 watts at any one time, and that's a fair amount of electricity. 2,000 watts is 2 kilowatts, and around this area that's about 40 cents. So using this each hour is about 40 cents. If you're watering your lawn about 3 hours a day, which I'm doing, that's about $1.20 a day, which is a fair amount of money for electricity. But we are saving a lot of money because we're not paying for the water. Like I said, my water bill dropped from between $150 and $200 to about $25, $30 or so dollars a month. Okay, so now it's running, still at 8.1 amps, and let's see what happens. It's not that loud, and right now it's powering the first zone, which is in the front. So let's take a look at the water. We'll turn this on. And we'll check it out. Here's the hose. Now what you can see is, oops, I don't want to get the camera wet. Let's try this way. There's a fair amount of pressure here. It's going about, I don't know, about 20, 25 feet. There's a lot of water coming out. You can see there's some air in the system. We just turned it on, so you do get some air. And there's a ton of water. It's really a lot of water. And because that's water running even with the zone 1 running, so it's sprinkling the front of the house. So you're getting a lot of pressure. The other thing to note is the water in this area is poor. On Long Island, the municipality sends us water from their wells, and the water has a ton of iron in it and sulfur, and you need a whole house filter, and it just keeps stuffing up the filter, and the water tastes terrible, it smells terrible, so it's really a problem. Here, the water that we're getting from this well, which is about 35 feet underground, also tastes terrible, smells terrible, but I'll show you, but it really is pretty good. It's excellent for watering your lawn, but you can see let's take a look at it. I don't know if you can capture that. I've tasted the water. It tastes a lot like the municipal water. High in iron, you can taste it, it smells from the sulfur. Let me just shut this off. And the water, it's a little dark from what I see, though the truth is, it's the first run of the season, so it may just be a little darker than usual, but it's not bad. I haven't noticed any staining on the concrete. People ask me about that a lot. They heard that you'll ruin your concrete, it'll turn brown. I haven't noticed any staining at all. I'd say this is about what I'm getting from the municipality. Though there are some bubbles in it. I don't know why exactly. That's usually not the case. Though I did run, this is the first run of the season through the hose, so it just may not be that clear. But in any event, the water is certainly fine enough for watering your grass. The grass, as you can see, the bushes really are pretty lush. And we're doing great. I'm even using it for my garden. Basically, I have the sprinkler heads here, and we're running it. We're using it for the garden. You pretty much don't want to drink this water because it probably has some level of maybe perhaps some pesticides in it, or perhaps all of the fertilizers that from the grass, but it seems pretty clean, and certainly for watering the grass, it's fine. Okay, over and out. If you have any questions, just post it, but I highly recommend it because the cost of this system is basically between about $2,000 and $2,500, and you're pretty much making it up after about 4 years or 5 years. There is some maintenance. You do have to have a contract with them. I don't like having a contract with them, but I'd rather try to do it myself. But I have found that it's a little difficult getting it running the first time, pulling the water up to 35 feet. Also, they have to blow out that pump, and before the winter, they blow this out, this part of the pump, and then they pump in some kind of fluid that keeps it from, not only keeps it from freezing in the winter, but also keeps it oiled. So, I mean, they really know what they're doing, and it seems reasonable to have a contract. So I would recommend having a contract. I think the only other thing I mentioned is, this is pulling off the 240 volts off of the air conditioning unit. In this case, we had enough voltage to do that, but you may want to consider running its own line directly from the fuse box. That's really how I would recommend doing it. But with electricity, a lot of things are just a matter of compromises, and I think this is perfectly safe, and you can certainly do this if you would like. And that's it. Any questions, you can just post the questions, and I'd be happy to answer them. Be well.